Hi, welcome to Parametric Equations, Day 2. Today is more of a practice day than anything else. If we were in class, you would be doing these 4 problems in your notes on the big whiteboards and checking your answers and then moving on to the practice itself. So I'm going to call it a warm-up, but it's actually problem 1 from the notes from Parametrics Day 1. I told you when we did those notes that we were going to skip that till today because today this is a little more involved. We've got to think about some domain questions to be able to finish this problem out. So we're going to do that, and then I have attached in Canvas the solutions to all of the 4 problems in your notes. So try working those 4 problems out, make sure you know how to do them, and then you can get on Canvas and check your answers. Okay, so the one that we skipped from yesterday was sketch the curve by eliminating the parameter, and we had an x equation of 1 over square root of t plus 1 and a y equation of t over t plus 1. So just like we've been doing, we're going to eliminate the parameter. And so when we look at the problem, we don't see any trig functions, so we're not using trig identities. So in order to eliminate the parameter, we're going to solve for t in one of the equations, and then we'll make a substitution to figure out the actual rectangular equations. So you have to kind of decide what looks good to you, and you could technically go either way, solve for whatever t that you wanted to solve for. But since there's 2 t's over here, I'm going to go ahead and solve for this one because it only has a single t down there in the bottom. So I'm going to take x equals 1 over square root of t plus 1. And then to get down here to the bottom, I need to kind of get rid of that radical. So in order to do that, I'm going to square both sides of my equation. So I have x squared equals 1 times 1 is 1. Square root of t plus 1 times square root of t plus 1 would be square root of t plus 1 squared, or just t plus 1. So once we've got that t out from the radical, now I can just go about isolating and getting t by itself. So now I'm going to multiply both sides by t plus 1. And so over here I have a monomial multiplied by a binomial, so I'm going to distribute through. So I'm going to have tx squared plus x squared, and over here these things are going to eliminate, so I just have the 1. So I'm almost close to getting t by itself, so I need to move the x squared over. So tx squared is going to equal 1 minus x squared, divide by both sides by x squared, so I'm going to have t equals 1 minus x squared divided by x squared. And so what we just did was to get t by itself so that we can do our second step, which is to substitute into the y equation. So that is this one right here. So I'm going to say y equals, and there's a t value on top, so I'm going to put parentheses right there. And then I have a t value on bottom, so I'm going to parentheses right there, plus 1. And we just found the something that goes in all of those parentheses. We just worked that out right here. Okay, so that means I get 1 minus x squared over x squared when I plug into the top, and 1 minus x squared over x squared when I plug into the bottom. So really y equals 1 minus x squared over x squared over 1 minus x squared over x squared plus 1. So we get that complex fraction, which we can't have. So the easiest way to get rid of those extra denominators would be to multiply the top fraction by x squared and the denominator by x squared. So what happens in the top is then those are going to cancel, and I have y equals 1 minus x squared. And on the bottom, when I distribute through, the x squared is going to cancel with that x squared. So I'm left with 1 minus x squared from the first distribution, and then when I multiply that by there, I get plus x squared. So hopefully you can pretty easily see that your rectangular equation is going to be y equals 1 minus x squared over 1, because those are going to cancel, or just 1 minus x squared. And so there is your rectangular equation. Okay, so once you have your rectangular equation, then we should always take a moment, stop, and look at what we have. So thinking about this rectangular equation, we know that it is a parabola because it's going to have that curve, that x squared curve. We know because the x squared is negative that it's going to open down. We know from this width of 1, it's the same as the parent function, but the 1 is going to be a vertical translation up 1. We know that the vertex, because of its translation, is going to be at 0, 1, and we know that the domain for any parabola is from negative infinity to positive infinity. So those are all of some of the main things that we know. So when we get down to the end and we're looking at our solution, it should make some sort of sense based on what we know about that equation from Algebra 2. Okay, so now we've got to think about the orientation table. So the orientation table is going to be derived with our 3 columns, and they didn't tell us what time to use, so we have to kind of work through that. And we do that by looking at the domains of the function. So the first thing I'm going to notice in that x equation is I have something about t plus 1 under the square root. So I know that for general purposes I can't take the square root of a negative number. So what number is, well, or even anything negative there, but I need to know where all of this in here is going to turn to 0, because the smallest value I can take the square root of is 0. So t plus 1 equals 0, so t equals negative 1. So then what that means is this equation, t, has to be greater than negative 1. Which is great, except it's not just the square root of that, it's 1 over the square root of that. So we have to kind of refine that a little bit more, because since the square root is in the bottom, yes, I can actually take the square root of 0, but I can't take the square root of 0 when it's in the denominator of my fraction. So I have to further limit this because I need to know what would make the denominator 0. So then I know that t has to be greater than or equal to 0. Okay, so since that is true, then the x equation is going to be greater than 0 because it has that numerator of 1, and we already kind of took into consideration what's going on the bottom. So when I set my t table up, I'm going to have t, and then my x is going to be 1 over square root of t plus 1, and then my y is going to be t over t plus 1. And I usually put those in the headings of my table just to keep me from messing up. You could just say txy, that's up to you. Okay, so I know that it's got to be greater than negative 1, so I'm going to start my time at negative 1 so I know where that point is. I know that it's going to end up being greater than or equal to 0, so I'm going to have a 0. And I'm just going to get a couple more points past that so I'm good with my orientation. Remember, we said last time that the minimum amount of points in an orientation table should be 3. It could be more. And if they give you specific ones, you'll have to go with those. Alright, so what happens here? If I plug in a negative 1 here, I get negative 1 plus 1 is 0. Uh-oh, can't take the square root of that, so it's undefined. And then when I come over here and I put the negative 1 in here, negative 1 plus 1 is 0. Oops, that gets a 0 in the denominator, which I can't have, so that's undefined. So now I plug in my 0. So I get 0 plus 1 is 1, square root of 1 is 1, 1 divided by 1 is 1. And then I put my 0 in here. 0 plus 1 is 1. A 0 on the top makes the whole fraction equal 0, so that's just 0. So if I put a 1 in, I get 1 plus 1 is 2, or 1 over square root of 2. I don't usually like to write that diagonal fraction like that, but I'm trying to make it fit on here. And then when I put the 1 in here, 1 plus 1 is 2, and 1 over 2 is going to give me 1/2. And we know that 1 over square root of 2, if you want to check that out, I'm just going to get an approximation so we know is 0.71. And then when we do it with 2, 2 plus 1 is 3, so that's 1 over square root of 3, which is getting closer and closer to the halfway point, so this could be about 0.57. Or technically you could have said 8 if you round. And then when you put it in over here, I put the 2 in the top and the 2 in the bottom, so I get the fraction 2/3. And so that's going to give our orientation. Well, what does it mean when we have -1 is undefined? Well, that means when we're here at -1, there's no graph, right? There's nothing in the y's, there's nothing in the x's, so at -1 there shouldn't be anything. At the point 0, or time 0, excuse me, then I'm at 1, 0. Oh, sorry, there's 1 right there. Went on the wrong line, didn't I? So 1, 0. And then the next one is going to be about 0.71 and a half. So 0.71, here's 0.5, 0.71 here. And so, you know, half is going to be like somewhere in there. And then we have 2 at time 2. So we're at 0.57. And then we're at 2/3. So we're getting a little bit closer, like right in here. And then we end up here, 1, and it's open. So this is the graph, and the orientation has it moving that way. And so does that make sense to what we know? Well, we know t has to be greater than 0 for the bottom, or the bottom bar has to be greater than 0. So we know that it's a parabola from what we know up here, opening down, translated up 1. The vertex would be at 0, 1. However, I don't have that point, so that's what it looks like. So this was the problem 1, as I said last time. And I just felt like, you know, it's a good algebra practice and kind of thinking about domains again, because sometimes you do have to use that domain to help you set this table. And remember, a minimum of 3 points, and you have to have the arrows on your graph. So the next thing I want to kind of review from day 1 is, the process. So we eliminate the parameters to create the rectangular equation. If it's not a trig function, you solve for t, plug into the other one. If it is a trig function, you use an identity. Then you're going to identify the what we know. This is just a really good practice to get into to make sure that your answers are reasonable. We're going to create an orientation table, keeping the domain in mind to determine the orientation. That can help us with our time values, and remember a minimum of 3 values in the table. Then we're going to graph and show the orientation arrows on the graph, and then we're going to double check. Just take a minute, look back with what you wrote down for the what you know to make sure that you have the information kind of matches up. Alright, so now you have 4 questions in your note page, so go ahead and work through those 4 problems, make sure you're good to go, and then you can check those 4 answers on Canvas. So that takes care of parametric equations. The next lesson will be moving to polar equations, which will be kind of fun because those are graphing on a circular graphing system instead of a rectangular one. So make sure you've got your information good on parametric equations, and I will see you next time.